Today we're going to discuss the implicit differentiation. So, the history of it is Isaac Newton, he applied it to the various physics problems he came across. In addition, the German mathematician Gottfried Leibniz also developed the technique independently of Newton around the same time period. So, what is implicit differentiation? Implicit differentiation, each side of an equation with two variables, usually x and y, by treating one of the variables as a function of the other. This calls for using the chain rule. Here we treat y as an implicit function of x. The technique of implicit differentiation allows you to find the derivative of y with respect to x without having to solve the given equation for y. Finding the derivative when you can't solve for y. Implicit versus explicit. A function can be explicit or implicit. An explicit is y is equal to some function of x where we know x, we can calculate y directly. Implicit, some functions of y and x equal something else. Knowing x does not lead directly to y. So, the important to know implicit differentiation. It is allow us to find rates of change. For example, it all allows us to find the rate of the change of velocity with respect to time, which is acceleration. It also allows us to find the rate of change of x with respect to y, which on a graph of y against x is the gradient of the curve. To calculate the it is also an example of real life situation is to calculate the profit and the loss in business using graph and to check the temperature variation to determine the speed or distance covered, such as miles per hour or kilometer per hour or etc. Example, find the dy over dx f x squared y cubed minus xy is equal to 10. Differentiating implicitly with respect to x, you find that 2xy cubed plus x squared times 3y squared times dy over dx minus 1y minus x times 1 times dy over dx is equal to 0. So, we are going to combine the like term and then going to transpose the 2y in the right side. So, 3x squared y squared dy over dx minus x dy over dx is equal to y minus 2y cubed. So we are going to transpose the 3y squared and 3y squared y squared negative x into the right side. Going to transpose. So the result is dy is equal to dx, or implicit differentiation is equal to y minus 2x y cubed over 3x squared y squared minus x, or dy over dx is equal to xy cubed minus y over x minus 3x squared y squared.